Okay,
आवाज ही
fine.
आपकी रुक गई थी।
नहीं, वो actually there was a problem with the internet. ठीक है, मैं I was almost offline. ठीक है, so now I will start. Just रुकिएगा बेटा, एक second. So here we are going to discuss about the process at the constant pressure. So in this case, what will happen that when the heat is absorbed by the system, the in order to maintain the pressure constant, the volume will expand here. So work will be done by the system in this scenario, and volume will expand while the pressure will remain same here. So this process is explained by graphically figure 1911b, and you can see here that when the temperature is increased from the volume is increased from the initial stage I to the finest F, the pressure is kept constant and the temperature is changed from T to T plus delta T. So volume change in the volume was delta V. So in this sort of the scenarios or the experiments, what they have said that the heat related to the temperature by this relation. Okay, so this is the relation by which we can relate the heat that is absorbed by the system. So again, you can see here that it is dependent upon the number of the moles, and the second thing is molar specific constant as Cp, molar specific heat at constant pressure, while delta T is the change in the temperature. The you can say that the only thing that you should remember or you should be careful is that in the case of these processes like molar specific heat at constant pressure and the molar specific heat at constant volume, the constant like Cv and Cp, the difference between them is that Cp will always be greater than the Cv. So if there will be an MCQs that I will give you, you should remember that Cv will always be less than Cp. Okay? The molar
यस
specific heat hot constant for the constant pressure will be greater than the constant volume. So the reason for that one is in this case of the scenario, because during this type of the experiments in which we keep the pressure constant, the heat absorbed by the system does not only change the temperature, but it also increases the volume. So it does work on the system. Work is done by the system, and also the temperature of the gas increases. So therefore, Cp will always be greater than the Cv. Okay? So always remember this point and for the MCQs or the conceptive questions. Okay? Again, in this case of this scenario, okay, we will relate the Cp and Cv using the first law of thermodynamics. Again, first law is that the total internal energy of the gas is equal to, yeah, change in the internal energy of the gas is equal to Q minus W. So we will use the value of the Q, which is NCP minus delta T. एक second बेटा, admit हो रहे हैं here. We will use this here. Okay, W, for you know that W is equal to P delta V. We calculated this relation, and we also know that PV is equal to nRT. So if we are taking P delta V, so it will be equal to nR delta T, like here in this case. So when we will put these values in these two equations here in this scenario, so the end result will be equal to this one by dividing the n delta t. So algebraically you can do it. So if you have a copy pencil, ठीक है, मैं आपको या तो कैलकुलेशंस करके दूं. एक सेकंड आप ये करें. I think each and everyone have their copy and pencil. So what you have to do is के एक सेकेंड।
सर वैल्यूज ही पुट करनी है उसकी, क्यू की और
बस
डब्ल्यू।
क्यू की और डब्ल्यू की, और एट द एंड यू विल डिवाइड इट बाय एन डेल्टा टी। अगर आप में से अभी 2 मिनट लें और जल्दी से इसको कैलकुलेट करके बताएं, ये रिजल्ट बन रहा है आपके पास कि डिफरेंट है? ठीक है, जल्दी से करें।
यस सर, बन गए।
बन गया, क्योंकि CV इट इज बेसिकली इक्वल टू 3/2R। ठीक है, यू ऑलरेडी नो। तो जब आप कैलकुलेट करेंगे ये सारी चीजें, तो ये अब आपके पास जो है रिलेशन जो है ये बन जाएगी। ठीक है, सो इट मीन्स कि यू कैन डू इट इजीली। ठीक है, तो ये दिस इज रिलेशन। ठीक है, सो फ्रॉम हेयर, एक सेकंड बेटा, CP will be equal to what? CV plus R। ठीक है, again now he is saying कि आपके पास this relation is agrees with the experiment not only for the monatomic gases but for all the gases in general. Again, with the condition that they have lower density, means that we can consider a normal gas as an ideal gas only when they have very small densities. ठीक है, means that they are very far apart from each other. So this is what he is saying here. So this is the relation for the constant molar specific heat at a constant pressure, and then later on he has used this figure in order to explain that this is the process for the, as I was telling you, that at constant volume the value would be smaller compared to the smaller specific heat at the constant pressure. So you can see here that at the constant pressure it is 5/2 nr delta T, and for the this one it is this one. Okay, so this is for the monatomic gases. Again, एक सेकंड बेटा, एडमिट कर लें। These two values are for the monatomic, and again for the diatomic you can see here that at constant volume they will have a value 5/2 RT, and at a constant pressure they will have a value 7/2 nRT. Okay, for the polyatomic it would be equal to 3R as they have explained in the table. So is it clear for you?
यस सर।
कि मैं रिपीट कर दूं इसे सारी फिगर को दोबारा?
यस रिपीट करते हैं।
Okay. First one is the heat at constant volume. This will have a value of, क्या है आपके पास, किसके बराबर आएगी? इंटरनल एनर्जी 3/2 nr डेल्टा टी के बराबर आ जाएगी। ठीक है, एंड दिस इज फॉर द कांस्टेंट प्रेशर। सो द इंटरनल एनर्जी इन दिस केस क्या होगा आपके पास? It will only be consist of the translational energy for both cases, because we are dealing with the monatomic gas, as you can see here that they have mentioned. And plus in this case, in the constant pressure process, with heat is also doing some work here in both cases, not only increasing the internal energy but also increasing the volume. While in the constant volume process, it is only increasing the internal energy, meaning that it is only increasing the translational kinetic energy of the atoms here. Okay, so when you have a diatomic gas, so in that case of the scenario, for a constant volume process, the heat is only increasing the internal energy, but internal energy in this scenario is equal to both rotational energy and that of the translational kinetic energy. And when we will deal with the constant pressure, so at this point, and it is not only doing work, heat absorbed by the system is not doing only work, but it is also changing the internal energy, and again internal energy is dependent upon the rotational and the translational kinetic energy. So is it clear, beta?
जी सर.
Any question up to this point?
No sir.
चलें, गुड हो गया. असीब तो लगता दिल पे ही ले गया मेरी बात को.
सर इसीलिए नहीं बोल रहा हूँ.
नहीं सर, ऐसा नहीं, साथ साथ
Feel
पॉइंट
कर
नोट
लिया
कर रहा
ना.
हूँ, इसलिए काफी बिजी हूँ.
अच्छा 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 अच्छा. मैंने कहा नहीं तो
असीब अच्छा बंदा है.
माजरत कर लेते
नो
हैं
सर, वी
बेटा.
डोंट डू दैट ओवर
नहीं.
हियर. ऐसे वैसी बातें दिल पे नहीं लेते.
अच्छा चलो. अच्छा जी चलें. तो ये बेटा आई थिंक क्लियर हो गया सबको ये पॉइंट्स. ठीक है. तो अब ये है कि मेरा ख्याल है देर इज जस्ट होल्ड ऑन ए सेकंड बेटा, ये सेव कर ले. आई थिंक दिस वाज द लास्ट आर्टिकल ऑफ योर चैप्टर, दिस चैप्टर as per your course outline. Then we will move toward the next chapter, which is about the second law of the thermodynamics and about the entropy. So next time we will deal with, एक second beta. Yes, there is a problem with the monoatomic and that of the gases here. एक second. Okay, so a bubble of 5 mole of helium is submerged at a certain depth in liquid water. ठीक है. When the water undergoes a temperature increase, ठीक है, delta T of 20 degrees centigrade at constant pressure. As a result, the bubble expands. Since we are dealing with the constant pressure, so obviously the volume will increase. The helium is monoatomic and ideal gas. These are the conditions that he has given us. Okay. So how much energy is added to the helium as heat during the increase and the expansion? So for the constant volume process, we do know the equation which is equal to this one. ठीक है. Also we know that Cp is equal to Cv plus R. So we will use this relation Cv plus R. So we know that Cv is equal to 3 by 2 R. एक सेकंड रुकिएगा. एक पास बेटा ये आ जाएगा Cv is equal to 3 by 2 R. Again, R is the gas constant. ठीक है. Overall, the relation will become something like this one here. And when we will put the values, all the values are now given by. So when we will put the value, this is the value of the heat that is basically added to the helium during the increase and the expansion here. So second question, is it clear, beta?
जी सर.
Any question up to this point?
No, sir.
चलें, गुड हो गया. So in the next scenario, कहता है कि next question, what is the change in internal energy of the helium during the temperature increase? ठीक है. We want to find out the change in the internal energy. So for that purpose, what we are going to do is that we are basically use this equation here. Again, the value of Cv is known, which is equal to 3 by 2 R. So we will just put the values because change in temperature is 20 degrees centigrade as mentioned this statement. So we will put like in the previous case and the change in internal energy would be this one. So finally, he is asking about the how much work will be done on the system. ठीक है, because it will expand here. So the thing is, we know that W is equal to PV, or we can say P delta V, because there will be a small change in the temperature, so there will be a small change in the volume. So P delta V, as previously we considered that it is equal to W is equal to NR delta T, which is equal to this one here. और we will put this, बेटा एक सेकंड होल्ड कीजिएगा, एक सेकंड. जी बेटा. So now in this case, आपके पास क्या आ जाएगा? You will just put the values and this is the answer. ठीक है? I think this numerical is not that much difficult, and just you have to use certain relations in order to. And there he is saying that there is another way by which you can do this, and the other way is that you will use the first law of thermodynamics, from where you can calculate the work done, because total internal energy is equal to Q minus W. So in order to find out W, we will do W is equal to Q minus internal energy. You already have calculated the Q again from this equation. And in the second case, you also calculated the internal energy from the above B part. This is the B part here. So you will just use the values here in this equation, and the answer would be equal to 831 joule. ठीक है? So clear हो गया बेटा?
Yes, sir.
चलें, आज के लिए वो बहुत है इतना.
यस सर.
चलें, और ये चैप्टर आपका बेटा एंड हो है. ठीक है? सो नेक्स्ट टाइम क्या करेंगे कि हम लोग नेक्स्ट स्टार्ट करेंगे. ठीक है? जी बेटा, ये रिकॉर्डिंग मिल जाएगी बेटा? मैंने सारी अपलोड्स कर दी हैं, ये भी कर दूंगा बेटा. आपको मिल गई रिकॉर्डिंग
सर? MS टीम पर?
जी जी, MS टीम पर. आई हैव अपलोडेड ऑल द प्रीवियस पार्ट.
जैसे
मेरा ख्याल में मिल गई है बेटा, मैंने प्रीवियस अपलोड कर दी हैं सर. अच्छा, मैं आज वाली भी बेटा अभी कोशिश करता हूँ कि अभी कर दूँ अपलोड. ठीक है बेटा? चले.
ओके सर.
एनी अदर क्वेश्चन बेटा?
नो सर,
कोई मसला नहीं. ओके बेटा, फिर मेरी तरफ. जी बेटा.
सर हमारे कितने वीक्स रह गए हैं, क्योंकि हमारे मिड्स भी आ रहे हैं. तो
अभी मिड्स का तो बेटा कोई पता नहीं है. ठीक है? और जब मिड्स 19 को मिड्स हैं बेटा, लेकिन ये है कि अभी तो काफी काम है आपका बेटा. अभी तो ये नेक्स्ट चैप्टर आपका शामिल होगा मिड्स में.
सर कंफर्म है कि 19 को?
लेकिन
इंशाल्लाह
बेटा डाउटफुल है, कोई पता नहीं बेटा. अभी तक कोई अपडेट नहीं आई ना. जब तक अभी तक जो भी आपको अपडेट सुन रहे हैं, इट्स ऑल अबाउट द स्कूल्स. ठीक है? मतलब के स्कूल एंड कॉलेजेस. ओके, द कॉलेजेस विल स्टार्ट फ्रॉम द 9th April. School will remain closed till 28th April, and some are saying that they will open after Eid. So about universities, there is no notification yet. So let's hope they will issue the notification in a couple of days, and things will get clear. Okay? So right now you will prepare your midterm as per schedule. ठीक है? So as per your schedule, the midterms are about I think were on 19th April.
Yes,
I think.
लेकिन सर फिर साइकोमोटर परफॉर्मेंस नहीं होगी जो हमारी लैब्स वगैरह हैं, वो तो हुई भी नहीं है.
नहीं बेटा उनका एग्जाम्स भी नहीं होगा, ठीक है। देर आर नो एग्जाम्स फॉर द साइकोमोटर. So as per your notification, they were saying कि okay, after midterms you will be online on campus and perform the psychomotor. So right now again it is all dependent upon the notification, ठीक है. So most probable this notice it is that is up to 11th April. So after 19, after midterms, you will be on campus and you will perform the labs. ठीक है इंशाल्लाह. घर रह रह के थक
नो
गए
सर.
नो सर.
यस सर, यस सर.
सर अल्लाह करे रमजान भी घर में.
सर आगे रोजे आ रहे हैं.
कोई बात नहीं बेटा, चलें बेटा. अब जो जहाँ पे आप
अल्लाह हम सबके हक में
डिपेंडेंट के वो सब बेहतर करे. और दूसरा जहाँ पे आपका रिजल्ट लिखा होगा, अगर आप वो स्लाइड्स हैं तो आपका रिजल्ट पोस्टल में लिखा होगा सहरी अफ्तारी का, और तो आप आएंगे. अगर नहीं लिखा होगा तो आप नहीं आएंगे, ठीक है. सो डोंट बॉदर अबाउट दैट, कि जो होना है बेहतर ही हो. बस ये है, दुआ करें कि बेहतर जो आमतौर पे होता है बेहतर ही है जो होता है, ठीक है. अल्लाह मियां के हर काम में कोई ना कोई बेहतरी होती है. तो चलें बेटा, फिर अपना ख्याल रखिएगा. फिर इंशाल्लाह जो है कल मुलाकात होगी. ठीक है बेटा.